Okay, so today's video will be regarding Mathematics Syllabus D, Book D2, Chapter 10, Pythagoras Theorem. Okay, so the Pythagoras Theorem, it's mostly about a right angle triangle, okay, where the 90 degree, the right angle triangle, the opposite side of this 90 degree is the longest side, which is called the hypotenuse. Okay, so we'll be doing this Pythagoras theorem. The first question number 7 is regarding that, and the second question regarding converse of Pythagoras theorem. Okay, so going deep into this theorem. So what is this theorem basically? It's this hypotenuse square. It's equal to the sum of these two sides, square of the sum of these two sides. Okay, so for example, AB square will be equal to AC square plus CB square or BC square. Okay, or AB square equals to BC square plus AC square, which can be written down as C square equals A square plus B square. So this is the Pythagoras theorem. So what is converse of Pythagoras theorem? Converse of Pythagoras theorem is that if you have to prove that a triangle is a right angle triangle or a non-right angle triangle, then you use this converse of Pythagoras theorem. Okay, when proving in the case if it's a right angle triangle or a non-right angle triangle. So the first question will be regarding Pythagoras theorem and the second question will be regarding converse of Pythagoras theorem. So moving on to the first question, question number 6.
Start.
Okay, so in this question we are actually given two right angle triangles. Okay, so the first right angle triangle is PQS, the second right angle triangle is QSR. Okay, so we are required to find the length of QS first, then the length of SR. So how to apply Pythagoras theorem here? So for the solution to find QS in part 1, which is this length, QS is this length. So you are given the opposite of the 90 degree, which was, I explained it earlier, which was the hypotenuse or the longest side of the right angle triangle. And this we can take it as the base or the adjacent. Okay, so the hypotenuse square minus this base square will give you the length of QS, and square rooting it, of course. So we'll write the formula containing all of these three sides first. So PS square equals PQ square plus QS square. Okay, so now we'll fill in the values here. PS is 53 square equals PQ is 45 square plus QS square. So QS square shall remain here and this square will be subtracted to that side. So 53 square minus 45 square. Okay. So now we are done with this QS square equals 53 square minus 45 square. So this thing 53 square minus 45 square is giving you as 784. Okay, which you can tally it with your calculator. So QS will be square root 784, which gives you the length of QS as 28 centimeter. Okay, so this will be the solution to part 1. Now we will be continuing with the solution to part 2, which is SR. So first, filling in the details of the length of QS, which is 28 centimeter. So now you have found out the length of QS. So if you observe here, in this right angle triangle QSR, the side opposite this 90 degree, this 30, is the hypotenuse, which will be the longest side. Okay. So this will be the perpendicular or the opposite, and this will be the base or the adjacent. So following the same thing, the same formula of Pythagoras theorem. So the hypotenuse square QR square equals the base or the adjacent SR plus QS square. Okay, so QR is given as 30 square. SR, we need to find SR, and QS we found out in part 1, which was 28 square. Okay. So SR square will be this 28 plus 28 square will be shifted to that side and will be now minus 28 square. Okay. So using a calculator, try to find out 30 square minus 28 square. It's giving you a answer of this 30 square minus 28 square in the calculator is coming at 116. So square rooting 116 now will give you 10.77. Okay, 10.77, which rounded off should give you 10.8 cm. Correct to 3 significant figure. Okay, 10.8 cm correct to 3 significant figure. So that will be it. This is the solution to question 7 of exercise 10A. Okay, so moving on to the converse of Pythagoras theorem, we have a question regarding that of the exercise 10C, question number 2. In triangle PQR, PQ equals 19 cm, QR 24 cm and PR 30 cm. Show that triangle PQR is not a right angle triangle. Okay, we have to show that triangle PQR is not a right angle triangle. So if you come here to the converse of Pythagoras theorem, we have AB square equals BC square plus AC square. So the hypotenuse square should be equal to the square of both the other sides. So here, as you can observe here, the longest side out of these three is 30 centimeters. Okay, so we have to write an equation containing this PR square. Okay, it gives you this the summation or the total adding these two square of these two sides. So PQ square plus QR square. So if we have to show that it's not a right angle triangle, so this should satisfy this equation. So PR square should not be equal to the square of both the other sides. Okay, to confirm that this triangle is not a right angle triangle. Okay, so let's do the working here. So 30 square PQ square 19 centimeter. We are just substituting the values given in the question. Okay. So now we'll confirm here. Okay, so coming up to the next part, 30 square not equal to 19 square plus 24 square. So you can calculate the square of these two numbers in the calculator, which is coming at 937. So what is the square of 30? It's 900. So 900 is not equal to 937. So now you have shown that the longest side of this triangle is not, the square of the longest side of this triangle is not equal to the square of the adding of the square of the other two sides. So it's not equal. So now we have shown that triangle PQR is not a right angle triangle. So this will be the solution of question number 2 of exercise 10C.